let's start discussion about how to fetch a library from src folder for function object. Okay, so we know that function object is the, let's say, co-processing utilities. While the simulation is going on, we can get certain output with the help of the function object, and function object is give us the certain output, and that help us to understand how the simulation is going on. So first understand where exactly all the function object code is available inside the src folder. So go to the release version src folder. Look, function object is, even though going towards the while the run is or simulation is going on, okay, but it is part of the post processing, so that it fall under the post processing area. Inside the post processing you will see this function object, and when we say we have a certain function object available, so inside of that you will see couple of entries like function object in terms of the cloud info. Okay, so it gives us the certain values at some different location, depending on the, we specify the arrays of the point. Okay, that is one way you can look at. Then we have a fields, like we can look at the field averaged. Okay, how to take into account the field average of any of the quantities. For that we normally use this. Okay, function object field average give you the time averaged flow field in terms of the mean quantities, and the statistic in terms of the prime to mean quantities. Okay, so that we use when we talk or discuss about the some transient simulations. Okay, so that is the field averaged available. In the similar line, max min values. Okay, so max min values, we know that we can specify in the control dict something like this way. We say max min. Okay, function library name we have to specify. Along with that we can say the max and min of the particular field. So what it's going to do, it try to sweep across all the entire computational domain and give us the mean and max value and its location. So sometime it is useful to debug the diverging case, the simulation is diverging. Okay, then we have a field value, we can quantify the field value. Okay, so field value. Okay, so phase source, volume source, and we quantify the field value, and for that we have a average sum and weightage average. Some of the options is available. Okay, so this is all the source as a cell zone or a phase zone, two options available. Okay, so certain class of the object function already available. Okay, so near wall field, processor field, then streamlines. Okay, wall bounded streamlines, all these things we explore in basic and advanced module, how to use this function object. But let's say you have your own new ideas to look at the runtime simulation is going on, you have to take some output from your simulation. Then what we required, we supposed to have a template ready to go, and template is we supposed to take out from this src folder. We resolve the dependency and we construct the template, and then we try to utilize the template in any of the simulations. So how to do that, let's try to explore. For that what we try to do, we try to look at this forces. Okay, is a function object, and with even the force calculation is available, we are not going to change this, how to change the force calculation, but we just try to explore how to develop some class of the template for function object, so that later on whenever you need it, you simply modify the template and construct your new function object. Okay, so let's say we want to add up the some template. So I'm adapting from this force area. So let's first copy this entire all the files inside our programming area, and I constructed a new let's say directory, and inside the directory I'm again constructing, let's say, new name, my function object. Okay, I say my function object, that is the name of the directory, and under this directory I try to create my new function object. So let's say add up this and kept here. Okay, inside this my function object we adapted this. So before we go for further modification, simply go to the make folder and just look at the files. So inside the file we don't require, we just want to look at the force, not the force coefficient, and then we say, let's say user lib bin, and here I say my function object. Okay, so that is the library name I want to give, lib my function object, and it's supposed to fall under the form user lib bin. Okay, so in that area it is available. So before we go for further modification, just try to compile this and try to check either we have any error or not. Okay, so go to that area, construct the environment wclean lib, so we clean the library, and then say wclean lib so. So because we want to construct the dynamically linkable library. Okay, sorry, w make lib so. I type w clean lib so, that's why that is creating problem. So first make sure it's compiled and give us the up to date this output. If it is fine, now let's try to modify it based on our requirement. Okay, so first thing, I want to change the name as a my function object wherever possible. So first I want this force name is also my function object. Okay, so my function object is the name. Inside the my function object also, each file I gave the same name as a my function object. Same way, force, wherever there is a force, I replace forces in terms of the my function object. That's it. It's very easy. Okay, so we are renaming all the files. That's it, nothing any different thing we are doing. Okay, so we are set with this, and along with that we also change inside the this area my function object. Okay, and here also I say my function object. Okay, so this is the name I change. Then go to this area and try to modify it inside of this file also. So wherever I have a forces, I say replace the forces with the help of the my function object in entire of this document. Same way, wherever we have forces, okay, we try to replace with the help of the my function object. Okay, so everywhere we are replacing with the my function object. So now our runtime selectable name is my function object. Okay, so with the help of that name we are able to adapt our this new developed library. That is the idea. Okay, so everywhere we replace with the my function name. Okay, now let's say wclean lib w make lib so. So if library says it's ready to go, that means our template is ready. Now based on your requirement we can modify this template. Okay, for that we have understanding what we want from this particular function object. Okay, so depending on that we able to modify this particular function object. So our library is ready to go. Okay, now how to use this particular library? Okay, so this is says how to fetch the library. So we able to fetch the libraries very nicely. We resolve the names and dependency also. Okay, so we are ready with this lib function object as a new library. Okay, now let's try to run one very simple case. Okay, so with the help of that we at least know that our understanding about this function object is correct or not. Sometime what happen, we able to compile it, but when we go for actual simulation it give us certain errors. Okay, so make sure we not getting any errors. For that, let's say go to the some tutorial area. So let's say tutorial incompressible. Let's add up the OpenFOAM. Inside OpenFOAM let's add up this cavity, very simple tutorial. Okay, and let me go to the running area. Okay, so let's say case. Okay, and inside of it let's paste this area. Okay, so I constructed my function object as a name. So let me also rename it as a my function object, so we are consistent with naming. Okay, and inside that we construct the cavity. Okay, so inside the cavity, whatever we want to use this function object, it's supposed to goes inside the control dict file. Okay, so let's open the control dict file of this. Okay, here we don't have that function object, so first search where that function object is available. So how to search? We adapted this function object in terms of force calculations. Okay, so let's go to the area where it is installed, cd OpenFOAM tutorial, let's say incompressible grep, and we say forces. So wherever this force is available, it is available in this pimple dynamic control dict file. Okay, so let's open this particular case. Okay, and it says they include these forces as a include file, so we can open that particular force file. Okay, and this file we straight away able to adapt inside the our control dict file. Okay, and before that what we required these functions. Okay, so let's say functions. So inside the functions we try to adapt that our this force. Okay, so I say let's copy this area into our area. Okay, so here we adapted that force, but we don't want to calculate in terms of the force. Here we have, in case of this for our case, we have a top wall, that is the name for which we want to, let's say, calculate what is the forces is applied on that particular wall. Okay, so that is row fine. Rotational the impeller, let's delete pitch, x is not required, so that is perfectly alright. We only want to identify this name and we want to fix this force name and the library name. Okay, that is what needed. So later on we do. Before that, let's go to that area. Okay, and first try to look at the mesh and identify the top wall name. Okay, so we say block mesh. Okay, first construct the develop the environment, then say block mesh. So our patch name is moving wall. Okay, so on the moving wall we want to construct the all the forces. Okay, so that is the idea. So let's say this is the moving wall and we right now using the by default value. Okay, so output time step, time interval 1 time step. Okay, so let's first run this case with the ICO form, and okay, so in the transport property file, which file, transport property, I don't know why it is the set tutorial, then also it's saying some problem with the transport property file. Let me check what is there. KVT, okay, transport property, yeah, maybe name they want. Okay, so that is what needed. Fine. So along with that we also able to calculate these forces. Okay, and that forces also goes as output forces. Okay, and inside that we have this all the forces on the that particular wall. Okay, so this is still we are using the old function only because we didn't modified. If you look at in the control dict file, we still using the old entry only. So let's modify it based on our requirement. So let's first clean the case. So we have to know that what is the entry needed. So first of all, mylib so file is needed. Okay, so we have to use this mylib so file as compared to libforce file. Okay, so first this we required. And what is this type name needed? So that is available in this area. Okay, so what is the type name? We supposed to use this my functions object, that is the type name we supposed to use here as a my function object, and rest are same because we didn't change any change this code, we just simply want to look at the forces on the respective page. Okay, so with this, if we try to run it, we're supposed to get the similar output. Okay, so that is what we say my function object force output, sum of my function object, sum of moment. And now if you look at here, you will see forces. Inside that you will see my function object dot .dat file. Okay, so this is all entries inside of that particular files. Okay, so that is what my function object pressure and viscous and porous and momentum. Okay, so this is all the forces we have on that particular patch, okay, at a different time. Okay, so this is the output we have. Okay, and that is coming from this particular my function object. Okay, so that is what needed here. Okay, so and this all the properties and everything we are reading from the transport property area. Okay, so that is why you have a different entries here. Okay, so this is how one can fetch a template for function object and use it inside the code, and it's very easy to fetch the template. Main thing is that you first identify most relevant function object that you want to code. Okay, whatever you want to code, just find out most relevant to that particular class of function object. Okay, and fix it from this area. Okay, and adapt whatever is most relevant to you, and then you modified the required entries inside that particular file. And before you do go for any modification, always follow just only copy the folder, resolve the make folder, change the without changing name, only change the name inside the make folder. Okay, so that means here, and first only don't do anything, let it be everything same, just only change the name as a user libbin and give the new name and first compile it. Okay, then start changing the name, and then after name and everything is resolved, then you start changing the code. Okay, so go step by step. Okay, don't do everything at a time, otherwise later on you will don't know where error is constructed, and we have a very least idea how to resolve that error. Okay, one more thing, if you look at this particular folder, like here my function, so this is the two important file. Along with that, this is two additional file available. Okay, so that is just warping to make the code for the function object. Okay, so that is some warping file only. Okay, so you need not to change anything here, the main source code is here only, but that two file is required to warping the code. Okay, that is its structure, I say. Okay, so that is one can quickly change it. Okay, and if you want some further output, okay, so you can even change some lines inside of this particular files. Okay, so my output or my header, you can define info, okay, wherever you need it, and it give you the idea exactly that are you using your develop library or not. Okay, so sometime for debugging point of view, it is needed that we supposed to take that particular output. Okay, so in this this is writing object. Okay, we have some files, and inside the files we are keeping all these outputs. Okay, so we can give a header name also, and so many things that give us the exactly idea that this is the file what is generated depending on our new development. Okay, so few of the entries we supposed to know from this area. Okay, so this is a very simple way to code this function object. Okay, and then basic idea you add up first and then start modifying based on your requirement.